Hello, and welcome back to Intro to Computer Networking. This is part B of our video concerning networking components. And today we're going to be discussing the network core. And the network core is essentially made up of routers and switches as well as links. Routers and switches, we've talked about them a little bit before, but they're basically hubs through which data can flow. And so what they're going to do is forward data that they receive toward the destination that the data is meant for. And they're going to utilize a process called packet switching, which we're going to discuss in more detail later on. Now, between these routers exist links. And these links are mediums through which data is transmitted. So these links might be guided and physical, like, for instance, a fiber optic cable or an electrical cable. Or they might be non-physical, like an electromagnetic frequency. Wireless fidelity is a good example. That's Wi-Fi, and also cellular networks, and also satellites. If it's not feasible to have a physical link, it's more feasible to have a electromagnetic link through radio waves. So let's talk a little bit about how data might get moved through the internet. One method that exists courtesy of telephone lines, this is how telephone lines ran, is that of circuit switching. And what circuit switching does is it creates a dedicated connection between two computers. And so routers are going to select circuits between them. We call these channels. They're going to select a channel that runs between them and the next router, and they're going to mark that off for a connection between certain computers. So for this case, this computer up here is connected to this computer up here. And these routers have reserved this channel and this channel for use by those computers. And these channels are reserved even when the computers aren't doing anything. So until they manually disconnect, the router is going to maintain that channel as a connection between these two computers. And these computers may be hosts or cell phones or whatever. Now, there are some problems with this approach. There are positives. You have dedicated resources for your connection. And this is good. This is going to give security and balance and stability to that connection, and so that the data that you send always has somewhere to go. But as we begin to connect more devices, we're going to begin to see a problem with this. So let's say that we have a connection between this computer up here and this computer up here. Well, now down here we have a reserved link, a reserved channel. And now we only have two channels left up here because this channel is reserved for communication between these two computers. Now let's add the third set of computers. You can see over here there's a link between these computers. And now three of these channels are used up between these two routers. So this is maybe fine on a small scale, and maybe even good on a small scale. But as we add more and more computers, unless we increase the number of channels, we're going to run into problems. So now that this connection between these two computers has been established, there are no more channels. And so if you want to establish a connection between, for instance, these two computers, you're out of luck. And so this is the downside of circuit switching. The channels can be exhausted, and then whoever didn't get there first is unable to use the internet. And so this was decided to not be the optimal approach in most situations by networking engineers. And they invented a method instead called packet switching. And what happens with packet switching is that the hosts who are using the internet are going to divide whatever data they want to send into packets. And these are just small chunks of bits and bytes that are going to be sent through the network. And so these packets are transmitted into the larger internet, and at each router that the packet hits, the router is going to consult its local forwarding table. Now the router has input links and output links. And so the local forwarding table is going to read the destination address for the packet that's arriving to it, It's going to decide which output link it needs to send the packet on. Now, because the packets are split up, the router might decide to send different packets along different links. And this isn't a problem unless some packets are lost. We'll discuss what happens in that case in part 4. But once all the packets have been transmitted, the message is reconstructed on the other side. And so there are some challenges with this. Number one, routing algorithms at each of the routers. Instead of having a dedicated line, each router needs to calculate where to send the packet to. But in practice, this ends up not being that big of a deal because modern routing algorithms are very efficient. But another problem is that resources are going to be shared. And so this might mean that there ends up being a lot of congestion on your channel and that everyone might suffer because there's so many packets going through these routers that it's taking them time to process them. And we'll discuss that in further detail at part 4. But the benefit of this is that we're not wasting time on these links. We're not reserving, for instance, this red channel for communication between some number of computers, and this is going to decrease the amount of infrastructure that we have to have. And it's also going to mean that if you're not using the link, someone else can be using it. And so everyone can participate in packet switching at once, and everyone can stay connected as opposed to perhaps not having access. And this is why packet switching is going to be chosen ultimately by networking engineers as the way data is going to be moved across the internet. A good analogy for packet switching, and like I said, we're going to return to this road analogy, is traffic. And so packet switching is great if there's not a lot of traffic. You might suffer, though, if a lot of people are trying to use the routers that you have. And so circuit switching might have avoided this. If you had a private road to your destination, that would be pretty sweet. But it would be infeasible. And so packet switching, well, it's not optimal for perhaps an individual user. It's going to make sure that all users can get their data where it needs to go, and that everyone's going to get a piece of the pie. In our next video, we're going to talk about protocols and communication. If you'll remember in my first video, I talked about how the internet is made up of infrastructure and rules. Protocols and communication are the rules that are going to govern the internet. So we're going to touch on that next time. Please don't forget to like and subscribe, and feel free to comment any questions. I am delighted to respond to those and perhaps learn something new about networking myself. Thank you for watching.